Hey guys, what is up? This is Austin from the Crypto Gym. In today's video, I want to talk about another Ethernaut challenge, and this one's going to be called King. I was actually taking a course taught by Patrick Collins about security and auditing.
Affairs is sending a disciplinary auditor
With smart contract, because I'm trying to get into smart contract auditing. I've been a developer for a little bit, so I want to get into more of the security, more of the little nitty gritty bits. So I was taking that course here, and one of the things he talked about, one of the bugs that we found in the course, kind of corresponds with this challenge here. So I want to make this video, I want to talk about it and kind of explain my thought process and see if we can crack this contract together. So first up, let's talk about this contract here. So if we scroll down, we see we have King. The contract is called King. We're using pragmatability 0.8, so not subject to underflows or overflows necessarily speaking. And we have an address king, we have a uint public prize, we have an address public owner. The owner of the contract seems to be sort of like the admin. And then we have the king, we have the prize, and then we have a receive function, and then we have the king. So the receive function, basically what's going to do here, it's going to make sure the message.value is greater than or equal to the prize, or the message.sender is the owner. If that's true, then the payable, the king, gets whatever value that's sent to the contract, and the message sender becomes a king, and the prize gets updated.
Yes, you will become king.
So essentially, whoever sends more ETH to the contract becomes the king each time. It kind of rises up and rises up and rises up. So our goal is to break the game here. And this is one of the things that, like, if you're a smart contract auditor, if you're a hacker, if you have that security mindset, this is something you're going to think about here. If you're just a developer, you're just going to build the application, this might not be something that you think about. And this was something cool that I saw with myself, that when I was just building contracts, I didn't realize some of the stuff. I didn't realize some of the flaws in some of the smart contracts I had. Luckily, none of them had this flaw here. And it's kind of cool to think about the different mindsets even within smart contract engineers. But anyways, here, let's go ahead and get a new instance, and let's go ahead and confirm the transaction. So the transaction went ahead and went through. I'm going to go ahead and copy this contract here, and I'm going to move it over into Remix. I'm going to hit OK. And those are all the other videos and stuff I've been working on. Let's go ahead and collapse that down. And let's go ahead and take a look at this contract here. So the goal is to break the contract here. And right away what I'm seeing here is we're sending ETH. And if we send ETH to a contract, what we can do is we can call revert on the receive function here. So I'm going to go and make another contract, and we're going to call this hack. And let's open this up here. Just like the king contract has a receive function here, we're going to call receive here, receive, external, payable, and we're just going to call revert, like that there. So anytime funds try to get sent to this contract, it's going to revert the entire transaction. Now, of course, this isn't going to work right away, because what we have to do is we have to make a constructor. We have to make this payable. Oops, payable. Always helps if you spell it right. And we also need to set up a target address here. So first up, we're going to say address. Let's make it public. Why not? Target. And let's take an address during the constructor. And we're going to call it target. And we're going to set target equal to underscore target. And so let's make another function from here. Let's call it function. And we're going to call this become king public. And I guess technically we could make, my thought process was when we deploy the contract, we'll give it some funds. Let's go ahead and just give it funds in the payable, excuse me, in the become king function. Public payable. Cool. And what we want to do is we want to send some funds to this contract here. Now what I want to do is I want to see what the current price is. This way I can send more to it. So I'm going to go back to Ethernaut. I'm going to go and hit F12 on my keyboard, and let's copy the instance address. Copy that, back to Remix, and we're going to go to this tab, the deploy and run transactions. We're going to drop down to inject and provide a MetaMask. And then we're going to select the king contract. And we're going to load this address here. And let's take a look at the prize. So right now the prize is 1, 2, 3. Let's just copy that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Count that out. So we have this much way is the prize, and we have to send either equal to that or more than that in order to become the king first here. So now let's go ahead and send the king contract some value here. So we're going to say, first off, let's go set up a bool, call it success, excuse me, comma, and bytes. Let's call it data, and it's going to set equal to target dot call, and we're going to give it some value to call. So we're going to say value equal to address of this dot balance. Now, if you want to be really verbose, you could put in an exact value here. I know that when I'm going to call this function here, I'm going to give the exact amount. So I'm just going to say the address of this contract here, and then we're going to say in parentheses no data with that there. And we do need to add the keyword of memory. And then if we're going to require that success, it returns true. Otherwise, we're just going to say, I'm not going to say anything there. Cool. And then we can get rid of this variable here because we're not using that, but we are going to keep the comma. Cool. This is looking pretty good here. Cool. So I believe our contract is looking pretty good. I'm going to go ahead and deploy the hack contract now. Now, again, we need to make sure we have the address of the king contract. So I'm going to go ahead and copy this. And I'm going to select the hack contract. Cool. And we're going to deploy it with the king contract in mind. Again, if you want to be a little more verbose, or if you want to be a little more careful, you could set another function in order to change the target address here. Right now, I'm pretty certain that this is the correct address. So I'm going to go ahead and transact. I'm going to send this. So I'm going to go ahead and send this transaction, confirm. So it looks like that transaction went through. So that's going to be step 1. Step 2, go ahead and drop down the hack contract. Scroll down, and we want to become king, but we want to send some value to that transaction. So we need to select this much way, copy, paste that right there, and then become king, MetaMask notification, and we're going to confirm this from here. So it looks like that transaction went through. Hey guys, I realized that during editing I didn't explain why this works, so I just want to take a second here and explain why this works, why this is able to crack this contract and basically cause a denial of service. So essentially this is trying to send money to the previous king, right? So if somebody else sends money to this contract, it was more than before, the previous king gets the new prize, and the person sending that money becomes the new king here. So since this contract became the king here, a new king is going to try to come along, and they're going to try to take our throne. The problem is when this contract tries to send this contract some ETH, the whole function is going to revert because of this keyword there, right? So this contract is receiving Ether. It calls the receive function that says, oh, nope, revert the entire transaction. So now no other person can become king, and we're permanently king. So let's go back to Ethernaut here, and let's go ahead and submit the instance, and let's see if we got this one correct. And we're going to submit the transaction. Cool. And it looks like we went ahead and beat this level from here. So if you guys want anything at all, be sure to give me a thumbs up, comment down below, and subscribe. And I'll see you guys in the next video at the Crypto Gym. Take it easy, guys.